All right, so I have had a request to make a video for solving the missing values for ratio tables. So I'm going to be completing the top portion of this for bikes with my purple marker, and then I'll be doing the amount of tires with my blue. So we're comparing bikes to tires. So whenever I start off this, I know that I have 2 tires for every one bike. Okay, this ratio would be a ratio of 1 bike for every 2 tires. So I have several different relationships here that I see. I see that I have a relationship where I'm multiplying 1 times 2 to get the value of my tires. Just realistically, I also know that if I have 1 bike, I need 2 tires. And then we're going to have to figure out how many tires that we'll need for 7 bikes and 10 bikes. So a common way that we could solve this would just be to multiply our top row by 2. So 7 times 2 would give us 14 tires. And on the bottom row, 10 times 2 would give us 20 tires. So this shows me that I need twice as many tires as I do for every bike. Every bike will need 2 tires. Another way that you can solve this is you can see that there is a multiplicative relationship as well, moving from the 1 to the 7 and the 1 to the 10. I see right off the bat that 1 times 7, I wrote 2, 1 times 7 is going to give me an answer of 7. And if I have a multiplicative relationship on the top, I also need to have the same on the bottom. So that means 2 times 7 is also going to give us 14. So 1 times 7 is 7, 2 times 7 is 14. I can also tell that I have the same type of relationship with the top with the first and the last number. So 1 times 10 is going to give us how many bikes that we have here, and then on the bottom, 2 times 10 is going to help us solve for this last piece. Now, if we had, let's say that we were missing the 7 and we couldn't seem to figure out what this piece here was, well, I've already decided that I have a relationship between the bikes and the tires. Every bike has to have 2 tires. So I could also divide 2 by 2 to get 1, which was my answer here. I could also, if I didn't know this like I had when I had it covered up a second ago, if I said 14 divided by 2, then my answer would be 7, which was how many bikes I need if I have 14 tires. If I'm missing this value here for the number of bikes, but I know that I have 20 tires, I can say that I have 20 tires, and since I have twice as many tires as I have bikes, if I divide it by 2, then we have 10 bikes available. If you notice, we're using the constant of 2 in every single one of these. So that relationship is going to be constant throughout this ratio table. The next example I have for you is with cars and wheels. I know that every car has 4 wheels or truck that you would normally drive, and we're obviously excluding 18-wheelers and motorcycles and things like that. We're just talking about the standard truck or car. So if I want to figure out how to solve this, I know that if I have 4 wheels, that's just going to be representative of 1 car. So here's where I can start from. If I want to use my multiplicative relationship, I can see that I can either multiply 1 times 3. And since I'm multiplying 1 times 3, I have to go to my bottom for my wheels, and I also have to multiply that times 3. 4 times 3 is going to give us 12. And I'll write that in here in just a minute. And then from here, what would I have to multiply 4 times to get the value of 16 wheels? what would I need here? What do I need? I'm going to need a 4. 4 times 4 is 16, so that means I do it on the top as well. 1 times 4 is 4. Okay, we'll fill this out in just a moment. By looking at the information here, I know that there's a relationship between cars, trucks, and wheels. Every car and every truck has 4 wheels. Therefore, the relationship is, if I have the amount of cars, I can multiply that times 4, since each car has 4 wheels, and that should give me the correct answer for the value of the wheels. So 3 times 4 and 4 times 4. I know 4 times 4 is 16, and 3 times 4 is 12. We can also use this to go back and check our answer that we missed a second ago when we were looking at 1 times 3 to get 3. Well, 4 times 3 is 12. So we definitely have the right answer. We're getting the correct answer this way and this way. The last way would be if we divide. So if we covered up, let's say we're going to cover up these top 2 answers, and we don't know what those are. And I know that relationship is 1 car for every 4 wheels. So my beginning ratio is 1 to 4. My ratio on the second one would have been 3 to 12 and 4 to 16. At this point here, I can say, okay, well, I don't know how many cars I have, but I do know how many wheels. So since I know that there's 4 wheels for every car, I can just start at the beginning and I can say 4 divided by 4. 4 divided by 4 is going to give me 1. So that's how many cars I have. Whenever I have 4 wheels, I have 1 car. If I have 12 wheels, keep my constant in there, and that's going to leave me with 3 cars. And look, we have 3 cars. Last but not least, if I have 16 wheels, and I use my constant of 4 wheels per vehicle, that's going to leave me with 4 cars. And that's exactly what we got. The last one I will show you, would be related more to maybe cooking. And this has some fractions with it, so it'll be a little bit more challenging. We're going to be talking about sugar and flour. A lot of times when we're baking, we use sugar and flour. So we're going to say for every half cup of sugar, we need 1 cup of flour. All right. So from this point here, and I need to add a value down here. Let's say, let me think here. How about we make this 8? Make this 8 here. So we're going to have 8 cups of sugar. So we're going to have quite a bit of flour. So we can either use our relational thinking and say, well, for every half cup, I need 1 cup of this. So how many 1/2s do I need to add up to make 1 whole? Well, I know that I need 2 1/2s to make a whole. So I'm really just multiplying this by 2. If I needed to go backwards, I would divide. So if I was doing it the other way, I could say 1 divided by 2 equals 1/2. And that's true. All right. If I don't know the value of the sugar, I can divide 4 divided by 2. And that's going to tell me that I have 2 cups of sugar. And then last but not least, if I'm going back the other way, I have to multiply. Notice if I'm going to flour, I'm going from the smaller number to the larger number because we have more flour than we have sugar. I'm gonna have to multiply times 2. So I'm multiplying here to get this answer, but when I'm going back, I have to divide because 2 is my constant throughout. I just have to make sure I use the correct operation with it. So 8 times 2, that's going to give me 16 cups of flour. Now we can use what we call sometimes in class, we call it the rainbow method, but really it's just a way to find that multiplicative relationship. I know that if I have 1 cup of flour and I'm going to 4 cups of flour, well, this is just 4 times bigger. And this down here would be 16 times bigger. If I'm making this 4 times bigger, I also have to make this 4 times bigger. So 1/2 times times 4, 1/2 times 4 would give us 2. And how we can see that if we use repeated addition to replicate the multiplication, 1/2 plus 1/2 plus 1/2 plus 1/2. Well, this is 1 and this is 1. And 1 plus 1 is 2. And that's how we came up with that. Last but not least, this one is 16 times larger. So we would either have to multiply 1/2 times 16 to get 8, or we would have to add 1/2 16 times to get us to 8. I hope this video has been helpful. It gives you several different ways, including some addition, some repeated addition here. We used some division properties, some multiplication. We used some relational thinking up here, knowing what we know about bikes and tires and cars and wheels, and it helped us solve the table. So I hope this helped you, and if it did, give it a like or a thumbs up, and I hope you have a good day.